Kinematics, now including gravity. So what changes? Well, now we have acceleration being provided by gravity. The acceleration due to gravity is represented as a lowercase g. It is a constant value when close to the surface of the Earth, and it is negative 9.8 meters per second squared, where the negative indicates the direction, which it would be down or toward the center of the Earth. The acceleration of gravity can be used in any kinematics equation in place of acceleration. So let's do some examples. First, Megan's going to drop a basketball. Write this question down and then we'll work it. When doing these types of problems, it is important that you assign which direction is positive. In this case, all of the motion is downward, so we are going to say that down is positive. The displacement of the basketball is 10.2 meters down, so it is positive. The initial velocity of the ball is 0 since she dropped it, and since it is dropping, the acceleration is provided by gravity, which is 9.8 meters per second squared. We need to find V final, so that's our question mark. V final squared equal V initial squared plus 2AD is the only equation that fits this case. Remember, G is our acceleration. So plug in all of the values that you know and then put it into numerical solve in the calculator. Once you do that, you will see that the final velocity is 14 meters per second. Draw a box around your answer. Next, we will look at this example involving Calvin throwing a ball straight up into the air. Write down this part of the problem and write down all 4 of the questions, and then we will work the questions together. For the purposes of this example, we will say that up is positive. He threw the ball up with an initial velocity of 19.6 meters per second, and that is positive since it's up. Once he lets go of the ball, gravity provides the acceleration downward, so it would be negative. Oops, that little 2 shouldn't be there. Question A asks, what is the displacement of the ball? If he catches the ball at the same height that he threw the ball, then the displacement of the ball would be 0 because it stopped right where it started. Next, we want to know how long the ball is in the air. Well, there's only one equation that has V initial, acceleration, displacement, and time in it, and that would be this one. Again, plug in all the values that you know. Be especially careful with that negative sign on the 9.8. Solve the equation for t, and you get an answer of 4.0 seconds. Box your answer. Part C wants to know the final velocity of the ball as it comes back to his hand. Since the time was calculated in Part B, we want to stay away from using that. So this is the only equation that fits the information that was originally given. Since the displacement is 0, this entire last term becomes 0 and goes away. So V final would be 19.6 meters per second, but since it is moving downward, that 19.6 would be negative. Box your answer. Lastly, the question asked how high the ball was thrown. First, we have to recognize that at the highest point, the velocity of the ball is 0. So for this case, we will use VF equals 0. Again, since time was not given to us in the original information, we want to stay away from using that. So this is the only equation that fits the given information. In this case, the final velocity is 0, so this term goes away. Plug in everything that you know, and then you will see that the ball went a distance of 19.6 meters high. Box your answer.